dear student, I'm Mr. Kitwala from Educators. I will be with you in physics for Form 5. And today, my dear student, we are going to proceed with our discussion on our topic of wave for the subtopic of wave motions. So, my dear student, before we proceed with our discussion here, we should remember where we ended on the last session. On the last session, we tried to explain the principle of the superpositions. And we said that the principle of superposition can be started like this one. Imagine you have two waves, and those two waves, they are moving at, those two waves having the same amplitude, having equal amplitude, but they try to move at the same time. So the net displacement at any point might be equals to the vector sum of the individual displacement at any point. That is how you can state the principle of the superposition. And after there, we tried to see the bits. We say that sometime we'll be asked to define the term bits. We say that this bit imply as the amplitude variation in the sound due to the superposition of equal amplitude of the same amplitude, but it occur at the different frequency. Finally, we demonstrated the formula of obtaining the bit. Either we will be asked to find the period of the bit, and we can obtain the period of the bit either by taking the number of the cycle times the period, then is equal to the number also of the bit to the number of the cycle. We minus by 1, then we times it by the second period. That is why we demonstrated it on the last session. Finally, we concluded by saying that always this bit frequency must be equal to the reciprocal of the period of the bits. And we demonstrated it is a formula by saying that generally we can find the frequency of the bit by taking the frequency 2. You take the frequency 2, then you minus by the frequency 1. That is what we demonstrated on the last discussions. So the thing that we are supposed to keep on our mind is that when the frequency of the bit increase, this can cause at the time of the bits to increase. These two things can take a place inversely, kwamba kitokea kimojawapo kimeongezeka, basi kingine kitaweza kupungua. That is what we concluded on the last sessions. So for our today discussion, we are going to look at the example related with what we learned on at the last lectures. So we have our example number 2 for our topic number 8. And our examples say that two forks A and B. Imagine we have the two forks. We have the two forks. We have fork 1, which is labeled by a symbol A, and also the second is labeled by the symbol B. So when they sounded together, produce 4 beats per second. When this forks A and also forks B, they try to sound together. Then they produce the beats which is equal to 4. This beats per second means the frequency which is equal to 4. This is what we have been told, my dear students. The fork A is in a uniform with the certain length with the certain centimeter. This fork A was in the unison, and this unison, it means that it produced the length which is equal to 30 centimeter of a sonometer wire. The sonometer wire producing the length which is equal to 30 centimeter, as we have been told. So B is in the unison with 25 centimeter. This B was in the unison also. It facilitated to produce the length which is equal to 25 centimeter of the same wire. All of this, they use the same wire. It means the fork A use the sonometer wire, and also the foggy B, they try to use the same wire which is called the sonometer, but they produce it is lens which in unison, which is a difference. One of them is on 30 centimeter, and the second was on 25 centimeter. So, and this occur at the same tensions. The tension that exists on the fog A and also on the fog B was in the same, my dear student, as we have been told here. So, calculating the frequency of the fog. How can we get the frequency of the fog? This is what we have been asked on our today discussions. So, first of all, let us summarize our given values for our questions. For our question, we have the same frequency. It means we have the bit of the bit frequency, which is equal to 4 centimeter. You can summarize it by saying that the bit frequency is equal to 4 bits per second. And also we have this we have this the range of the fog A. You will try to label it, my dear student, to summarize it as a data given. Also, we have this the second range. You try to label. How can you find this frequency of the fog? So first of all, let us recall for the phonometer. And we know that, my dear student, when we was at the O level, we tried to discuss that we get the frequency of the fog by taking the reciprocal of the length. Now, we could say that the frequency of the fog must be equal to 1 divided by L, and this L implies as the length of that sonometer wire. Now, therefore, after there, let us imagine that, let us consider the two variation. We should focus for the fog A and also for the fog B, as we have been told, my dear students. Now, for the fog A, we should indicate this A. It means it must be the frequency respective to A must be equal to the constant divided by the length respectively to A. Also, for the fog B, we should say that the frequency along the B must be equal to the constant divided by the length along to B. Then after there, you have to take equation 1 divided by equation 2 first, and finally you could make it the frequency A at the subject. As we see here, we tried to make it the frequency A at the subject, which is equal to a frequency along to the B. Then we times it by the length along to the B. Then we divide it by the length along to the sonometer wire of B. And after there, let us take the data that we have on our equation, then try to substitute it into our formula, my dear students. As we observe here, we have the length of the sonometer wire B, which is equal to 25 centimeter, and also we have the length of the sonometer A, which is equal to 30 centimeter. I tried to substitute this data for the aim of obtaining the value of the frequency along to the frequency of the fog along to the sonometer wire A. As we observe, after substituting our given data, we tried to solve by taking the number that are found on the numerator. Then we simplified it by the number that are found on the denominator. Finally, we obtained the frequency of the fog along to the sonometer wire A is equal to 5 divided by 6 times the frequency along to the sonometer wire B. So after there, my dear student, we have been told that let us recall the equation number 80.8. This is the equation that we demonstrated on the last discussions. So this equation says that we obtain the bit frequency by taking the frequency along to the sonometer wire B. Then we add it by the frequency along to the sonometer wire A. Now, as we observe here, we try to recall that equation related with the sonometer of the wire, that related with the bit frequency that we demonstrated from the definition of the bit. And I tried to I introduced for you that this frequency of the bit might increase with the decrease of the period. If you recall that concept, you should substitute you should substitute the frequency of the bit which we have been given, my lovely student. Kwa tutakachokifanya pale, tuenda sasa tutasubstitute huyu frequency along to the beta b as we observe, which is equal to 4 beta per second. Then we add by the frequency along to the point b, along to the sonometer wire b. If you substitute, if you solve for A and also for B, you could obtain that the frequency along to the sonometer wire A might be equals, must be equals to 20 Hertz, must be equals to 20 Hertz, and also the frequency along to the sonometer wire B must be equal to 24 Hertz, as we observe, my dear student. Finally, we could conclude by saying that the frequency of the fork A is equal to 20 Hertz, and also the frequency along to the fork B might be equals to 24 Hertz, my dear. So this is the answer that we was being asked on our question to solve, my lovely students. So by saying that, let us stop here. We could come and proceed with the next part.